Welcome to the session number 1 from the playlist of Gravitation. So this is the introductory session, and in this session I will be briefly uh, discussing about the universal law of gravitation, the acceleration due to gravity, and the variation of the acceleration due to gravity with the altitude and the depth with respect to the earth. So as per the universal law of gravitation, every object or body attracts every other object or body with a force which is proportional to the masses of the bodies and inversely proportional to the square of the distance separating them. So if F is the force of attraction between the two bodies of mass m1 and m2, and which are separated by a certain distance, say r, then F can be written as that F is directly proportional to the product of m1 and m2 as per this definition, and inversely proportional to the square of the distance separating them. So F is proportional to m1 into m2 divided by r square, or simply we can say that F is equal to G m1 into m2 divided by r square, where G is what? This is the universal gravitational constant, and here small r is the distance separating the bodies of mass m1 and m2, and here the value of the universal gravitational constant is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now if the mass of the earth is capital M and if the radius of the earth is, say, capital R, then the force of attraction on the mass, or you can say on the body of mass M, which is on the surface of the earth, can be written as F is equal to Gm, that is capital M, and this is the mass of the earth. The small m is the mass of the body which is lying on the surface of the earth, divided by r square, where r is the radius of the earth. So this formula has been written in accordance with the universal law of gravitation. That is this formula, F is equal to G m1 m2 divided by r square. Now here the distance between the body of mass m and the earth has been taken as r, this capital R, which is the radius of the earth, because the mass of the earth is supposed to be concentrated at its center. So if the mass of the earth is supposed to be considered at this point, so let us say this is the center and this is the body of mass small m, then the distance between these two bodies will be equal to the radius of the earth. So F is equal to G capital this is equal to G into capital M into small m divided by r square, and now this force of attraction will generate an acceleration in this body of mass m, and this acceleration is called the acceleration due to gravity. The most important thing about the universal law of gravitation is that all the objects in this universe, they attract other objects with a force which is attractive in nature. This force is never repulsive. So from this formula, that is F is equal to G capital M divided by r square, which is equal to m into G, where G is the acceleration due to gravity, the value of the acceleration due to gravity will be equal to Gm by r square. So if I substitute the value of the gravitational constant, the mass of the earth and the radius of the earth in this equation, the value will come out to will be equal to 9.81 meter per second square. The radius of the earth, for your knowledge, is 6.4 into 10 to the power 6 meter, and the mass of the earth is equal to 6.02 into 10 to the power 24 kg. Now so this is the acceleration due to gravity on the surface of the earth. Now this value, this acceleration due to gravity, it varies with the altitude and with the depth with respect to the earth. So the value of the acceleration due to gravity at a height h is given by, here see, here G is equal to Gm divided by r square. Now at a height h, the same, this acceleration due to gravity will be equal to Gm divided by r plus h whole square, where h is the height, this is the height above the surface of the earth. And so this formula can again be written as g r square divided by r plus h whole square, because here gm is equal to, from this formula, gm is equal to g r square. So I have substituted the value of gm as g r square divided by r plus h whole square. Now if the radius of the earth is very large in comparison to the height, then in that case this equation can also be written as g dash, this is equal to g is what? This is the acceleration due to gravity on the surface of the earth, in bracket 1 minus 2h by r, where h is the height above the surface of the earth. So this is a very important formula. This is a very, very important point. And so these three formulas are very, very important from the point of view of solving the numerical problems. Now the value of g below the surface of the earth is given by this formula, that is g dash is equal to g in bracket 1 minus d upon r and bracket closed. Now here d is what? This is the depth below the surface of the earth. So in short, today I have discussed about the universal law of gravitation, the acceleration due to gravity, and the variation of the acceleration due to gravity with the altitude and the depth with respect to the earth. In the next session, I will be discussing in detail about the gravitational field and the gravitational potential. So till then, have a nice day. Bye.